Hello YouTube and welcome to another Juniper tutorial. So in this video I'm going to show you how to configure Spanning Tree Protocol on Juniper devices. So are you ready? Let's get started. So first thing first, what is Spanning Tree Protocol? Okay, so actually Juniper Networks devices provide layer 2 loop prevention through Spanning Tree Protocol. Okay, so actually on a Juniper world there are a lot of flavor of Spanning Tree. You can find, for example, rapid Spanning Tree Protocol, multiple Spanning Tree Protocol, and also VLAN Spanning Tree Protocol. But RSTP or rapid Spanning Tree Protocol is the default Spanning Tree Protocol for preventing loops on Ethernet networks. Okay, so here I have this simple topology here, which consists of two actually PCs connected through two Juniper QFX actually switches. They are data center switches because you can see here the interfaces are XE, which means 10 gigabyte Ethernet interfaces. Okay, so all what we have to do now is to configure this two switches in order to actually set up rapid Spanning Tree Protocol, because by default it's disabled. So here, for example, I am on the QFX01. If I do show Spanning Tree bridge, you can see that the Spanning Tree is not enabled. Okay, so we have to enable it, but before that we're gonna actually set up the interfaces for each VLAN, because here you can see that I am on VLAN 10. So if I do show VLAN, you can see that I have VLAN 10 which has a tag 10 but no interfaces on it. So we're gonna configure this interface here X001 as belonging to VLAN 10, and of course the interfaces between the two switches will be configured as trunk actually interfaces. So let's go and set up that on the first switch. So here I'm operational mode of my Juniper, so I go to the configuration mode using the edit command. Then I will set up, for example, this interface here X001 as a member of VLAN 10, and by default it's in access mode. Okay, so in order to do that, it's pretty simple. We have to enter the command set interface, and of course if X001, okay, unit 0, because we're gonna set up a logical interface, and here the family is Ethernet switching. Okay, and here we have to enter the VLAN members. So here I have to enter VLAN 10 as VLAN member, VLAN 10. Here we go. So it's pretty easy, pretty straightforward. Okay, but as I told you, by default interfaces are in access mode, but here for the interfaces 002 and 003 we have to convert them to trunk interfaces. Okay, so I will just hit up arrow in my keyboard and change here the interfaces to true. Okay, 00 actually 2. Then interface family Ethernet switching, but interface mode will be a trunk. Interface mode will be a trunk interface. Okay, and we have to add it also to allow VLAN 10 to go through it. So I will use the same command, but here I have to change the VLAN member to VLAN 10. Okay, and I will do the same for the interface X003. So exactly the same, I will convert it to a trunk interface. Here we go. So now it becomes trunk interface. So here I made a mistake actually, so let me say I have double slash here. I have, okay, and now I have to add actually to allow VLAN 10. Here we go. So we have added the whole interfaces to actually VLAN 10. And it's always good to verify that using the command run show VLAN to see if indeed the interfaces are belonging to this VLAN 10. But of course here it shows nothing because we didn't commit our changes. So let's commit what we have done. So we'll wait for a little bit for the configuration to get checked, and also to check if I have any thing here. So here please ensure that VLAN member is configured on inner VLAN list for the XE003. okay, so here if I do show config or show just to see the configuration for the XE003, so here 002 is trunk interface and it's member of VLAN 10, so everything is good. But for the XE003, here I have the interface mode is trunk, but I didn't add as a member of VLAN 10. Okay, so let's do that. So here I'll have to forget keyword members VLAN 10. Here we go. So this is the mistake. So let's commit that. So now the configuration is good. So let's do show VLANs to see if effectively all the interfaces belongs to actually the VLAN 10. And here we go, all the interfaces here belong to this VLAN 10. okay, so now that we have configured our interfaces, we have actually to set up RSTP or Rapid Spanning Tree Protocol for this switch here. So the configuration is pretty simple. All you have to do is to set protocols, and of course here we have to specify the protocol that we'll be using as spanning tree, which is RSTP. okay, and of course also you have to enter the interface that will participate to this protocol here. So I'll just see here all the interfaces. okay, and later we'll configure in just these two interfaces because they are the XE002 and XE003 are the one that actually should participate because they are connected to the switches. And this interface here, X001, doesn't need to participate in this process because it's what we call edge interface. It's connected directly to a PC here. So let's commit our changes here. Here we go. And we will do actually the same for the switch number 2. So let's go to switch number 2. I will go to config mode. Here we go. And I will set up the interfaces as we have done for actually first switch. So 001 will be actually also a member of VLAN 10, and by default it's in access mode. And the two other interfaces will make them as trunk interfaces. okay, and they should actually also allow VLAN 10. So this is for interface 2. So let's configure interface 3 as trunk, and I will allow VLAN 10 to go through it. Here we go. So let's commit that changes and see if indeed they are part of the VLAN then. With command run show VLANs to confirm our changes. Okay. Here we go. So if I do run show VLANs, I get all the interfaces belongs to actually VLAN 10. So now let's set up also RSTP on this second switch. So the commands is the same that we have done on the first switch. Set protocol RSTP, and here we specify that all interfaces will participate in the process. Here we go. So now we have configured RSTP on this two switches. Okay, so let's commit our changes, commit with double TM actually. Okay, and now normally this PC1 should ping PC2 because we have configured everything. So before actually checking the RSTP, let's do a simple ping from this PC1 to PC2 172.16.0.3. So here maybe we have to wait a little bit in order for the process or to allow the RSTP to converge. So we'll wait a little bit. So actually after a while, let's ping once again PC2 from PC1. Here we go. Now we have connectivity between the two PCs. Okay, so now let's see the config or actually the details about the RSTP or Rapid Spanning Tree Protocol. So if I go to switch 1 on the operational mode, and if I issue the command show spanning tree bridge detail, you can see here that for the local parameter of this switch, it has bridge ID, this actually priority, and the MAC address. So this is the MAC address of this switch here. Okay, but here you can see that also it has root ID, which actually the bridge ID. Okay, so here the MAC addresses are different, which means this root ID is the second switch here, which is QFX02. Okay, so if I go to switch number 2 and issue the same command show spanning tree bridge detail, so this is actually our bridge or root bridge. So here we have the same ID for the local and also for the bridge or root ID, which means this switch 2 is actually our root bridge. Okay, so all the interfaces on the root bridge are in the forwarding state. Okay, and here we can assume that one of the ports here will be in a blocked state in order to avoid actually loops in these two interfaces. So in order to see the state of the interfaces on the switch, so we issued same command, but instead of bridge here we enter interface. Here we go. So let me expand this window here. So here you can see that all the interfaces on this second bridge here are on the forwarding state, and all its rules are a designated rule. Okay, so this is very important if you want to see which port is blocked. So here, as I told you, in order to avoid loops in this link here, one of the ports here for the switch 1 will be in the blocking state. So let's go to switch 1 and issue the same command in order to detect actually which interface is in block state. And here we go. Here we can see clearly that the port XE003 on switch 1 is in the blocking state here, as you can see, and the role name is alternate actually role. Okay, so here, as I told you, our root bridge is the second switch, but we can actually set up root bridge whenever we want. So all we have to do is actually to change its priority. So here you can see that the priority consists of this 32,768 number, that MAC address, and normally the root bridge has the lowest priority. So we can lower this actually priority here in order to convert this switch into root bridge. So the command to do that is pretty simple. So I will go to the config mode, okay, and I will set its bridge priority to something lower than this 32,000. Okay, so I will set protocol RSTP. Okay, then here I will give it the bridge priority or 4K, which is 4096. Okay, so here remember, before we're doing this command, we will commit this command. The root bridge is the second switch. Now we will turn this switch 1 into root bridge. Okay, so let's commit that. And normally when issued command show spanning tree bridge detail, we'll have that the MAC address will be also here, which means it will become root bridge. So let's issue the command now, show spanning tree bridge detail, and here we go. You can see that now we have the same MAC address for the local parameter and also the root ID, which means switch 1 became the root bridge. So let's verify its actually interfaces. So before, this interface here 003 was in a block state, but now, as I told you, for the root bridge all its interfaces are in forwarding state. And here we go, you can see all its interfaces are in forwarding state. So let's go now to switch 2. So before, all its actually interfaces are all forwarding. Now one of the interfaces will actually be in blocking state because it's not a root bridge anymore. And here we go, the interface 003 is actually in the block state. Okay, so if you want to optimize things, you can also convert this interface here on the switch to an edge interface, which means it will not participate in the process of RSTP. So the PC will not wait a lot of time in order to actually get its states. So let's go to PC 1, or actually switch 1, in order to convert this interface to an edge interface. So I will go here to config mode. I will issue the command set protocol RSTP interface X001 into the edge interface. And this has no effect, of course, on the electing process. It's just we are actually telling the RSTP to not make this interface part of the RSTP protocol, because it has no sense, because RSTP work only between switches. So let's commit our changes, and we can do the same of the other interface, which is this interface here X001 on the second switch. So here I'm on the second switch. I will go to config mode and I will issue the same command. And here you can, if you turn back to switch 1, you can still see that we didn't change anything. We still have actually switch 1 our root bridge. Here we go. So here you can see clearly that switch 1 is still root bridge. Okay, and of course PC1 still can ping PC2 and vice versa. Okay, so you can see how easy it is to configure actually RSTP on Juniper devices. So Spanning Tree Protocol have actually a lot of benefits. It's provide link redundancy while simultaneously preventing undesirable loops. It prevents also broadcast storms, and it connects to devices that are not STP capable, such as PC servers and routers and hub that are not connected to other switches by using what we call here edge port. So that was just a brief video to show you how to configure actually RSTP or Rapid Spanning Tree Protocol on Juniper devices. As always, I hope it has been informative for you, and I want to thank you for viewing. Bye bye.